Oh jeez. Oh, I saw it. I saw it stutter. I guess the implementation isn't perfect. That's really cool. The like earth shader in the background as well. This would look awesome with anti-aliasing. Super cool. It's still like out of order. Okay, I gotta. We can't be looking at shaders forever. This one's pretty lightweight. That's a good one. Is it just gonna go up forever? That'd be great. Is that supposed to be an elevator? The infinity buildings. Yeah, it is supposed to be an elevator. That's a good reveal. That's really cool. Really great idea for a shader and like really good execution as well. Hello. You can have these as a wallpaper and just like fry your GPU all day, every day. Early today. Oh, did I make it to the stream faster? How do I do this? What's the GPU usage? Let's see. 66%. 60 cents. This is using 66% GPU to just like draw your wallpaper if you put it as your wallpaper. And that's a 3080 Ti. But presumably it would be smart enough to not draw it when you can't see it. So that is definitely a good one. I may actually do that. GPU go loud. What happens to mine? This is light work. What do you mean? Lightweight shaders. This one runs easily at 120 FPS. The ghostly Sierpinski. Oh. Only 70% GPU. What? Mine runs at 144. Well, I mean it's 165. The recording is 120. Okay. That's another good one. Holy smokes. Wait. Oh, I accidentally had multiple running. Gotta work, man. Gotta work. So I'm like wondering if I can get rid of this. Had those bookmarked. Let's see. So this is used right here. And it's a contact index. So I have these indices. But what if this was a array of references instead of something else? So it's you run into a bit of trouble. Like I could probably do a double equals or something. Can you like check the pointer? Because like I don't need to compare the object. Rust check for same reference. How do I do this? Ooh, PTR EQ. Ooh. Okay, so there is a thing. So I can use that instead of this. So that's solved. But then what about... What about the afterword? Can I do pointer arithmetic? Can I like find it relative to the start of the array? Let's see. What does it say? What do you say? SED PTR. Is this unsafe? No. I want to like reverse. I want to like get the index from the reference. Okay, what if I say that? Rust get rest index from reference vec index. Find the index. So I have a reference to something that's already in. So it's known to be in there. It points at something that is in the vec. Okay, chat. Let's say I have a reference to an item in a vec. How do I determine what the index of that item is using pointers? Arithmetic. Unsafe. Offset, no. So are you, is it dividing? Offset from. PTR. Buh. How does it know the size of the elements? Oh, I guess the item pointer is a type. So it's like a pointer to an element of type that, and that's where it gets the size from. T. I was hoping for a little bit less unsafe. Okay, what if I do const as pointer? Is this unsafe? No. Dot. Is this unsafe? Is this unsafe? Is this unsafe? Yes. So what is this thing? Calculates the distance between pointers. The return value is in units of t, the distance in bytes divided by the size of the memory. Okay, so that's what I was thinking about. Have you still got that huge collection of anime? Yes, sir, you know, 2 terabytes of anime. Okay. So I can conceivably figure out. Okay, what did it say? It said this one like that. So conceivably I could do that here. I could do like what? I guess I could T this. So it's like reference. How do you pointer this? Do it like this. Sure. And then it is and then what's the type here? I size? I suppose so. Item. Okay, I like that better. As. What am I smoking? Isn't that the exact? Huh? Oh, it's trolling me, isn't it? Surely, right? Surely this is a troll. Parentheses are required to parse this as an expression. Okay. Is this const? Const? Ooh, as pointer. Pointer. Why is this not const? Oh my god. Peter. 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 So. Oh. Shadow the slice method. Okay. Not const. Get your raw pointer at the start location. This is what? Oh, mute. Why? What if? Can we do like? Why do it be doing that? So this is const, but this gives a mutable pointer. Pointer. For no reason. Scammed. Okay, whatever, it doesn't matter. Yeah, so I'm curious why this doesn't like exist. Well, I guess the guarantees are kind of whack. This can determine the index of a reference to an item in the list. Item. Hell yeah, brother man. So now if I pass around references, I can get back the index for some silly business if I want to do some silly business. What is this? This is oh, I was trying to rename this because it's like intersect. It's like intersect T. I need like solve. Maybe I should call this solve instead of intersect. I think that's better. Wait a minute. Did I swap these? Hold up. Ray C. C Ray. Why is it opposite? Right. That's negative. That's right. Correct. I think I'm gonna do this just to make it the same as the one above. So like you see how this is minus self.velocity? Just to make it the same. Because like it'll divide out the sign. Wasm. I think Leptos is really cool. I'm like torn and in pain about what the UI should be for that, because once I saw that that unmaintained iced thing that can put iced into the web DOM, I was like, oh my god, imagine just like having a native UI that's a real UI, but then there's just enough to like also make it a native web interface. And like if you open the world record list and you can see like the players' names, you could just copy the player's name out of the browser, because it's an actual GUI. But there's no way I'm bringing in an entire web browser as a dependency for my GUIs. That's just not happening. Coffee is whack. It is a day old. I'm gonna go heat it up more. Isn't your demo like 100 lines of code or something? Okay, so this is like name move function into struct impulse, I guess. Leptosh is easy. I'm sure it is. It gets to build on all of the web infrastructure stuff. Okay, well, I'm gonna think about this more here. Instead of indices, it can be references to contacts. Oh. Uh-oh. Oh. I was considering making it a hash table. Depending on the memory layout of the hash table, you could like get the index from the key. If you already have the memory location of the index from the, I meant the key from the value. How the hell? Okay, so how is Rust hash table laid out in memory? Or I could just look at it actually. Hold on. Physics hash set. Where is it? Okay, hash set new. Default. I gotta sneeze. Default. Alright, so we're looking for info default. Base. Base. Hash set. Base. Doesn't exist. Cool. Alright, well, that's where my journey ends, unfortunately. Memory layout. Wahasha. Const collections. What in the tarnation? You can have a const collection? Isn't that like impossible? Okay, yes, hash set. Difference. The tarnation. Huh. That sounds useful. Huh. I'll have to remember that there's cool functions on hash set. Collect. Wow. Okay, I gotta know about this base. Okay, like this is just a shim to the inside. And it doesn't reveal anything. Wait. Oh, it's hash brown. The standard library depends on hash brown. Holy smokes. Why is the stream only 720p? That is a good question. That is a very good question. Why is the stream only 720p? It's not my OBS settings. It could be that the bitrate leaving of NVIDIA Engine is higher than Twitch wants. I do stream at 8 megabits. Maybe Twitch is more strict about 6 megabits now. So source quality is not available. Okay, well, apparently I can just look at hash brown. Simply. Oh, jeez. Good. Memory. How is it weighed out in memory? Hash table. Buckets followed by control bytes. As long as they're paired up. All right, give me that. Sure. H A. Set. Wait, the standard library can't use the standard library, can it? Well, I guess it can, but hash map to nothing. Yeah, okay. That's cool. Okay. Table raw table. Table raw table. A raw hash table with an unsafe API. Raw table inner. Bucket mask. Growth left. I wonder why that is implemented as like a difference rather than an absolute value. T. Oh. Okay, what? TC. What? A pony is a small horse. At the Withers, really? Huh. That's quite elegant. Oh. If the memory size of U size is less than the memory size of a ooh ah ah, is this not just min? I guess it's const. Okay, where am I? Hash table. Wow. Raw table. Okay, why did it say TC? T. What determination is T? Okay, so where? So why is map? Oh, okay. That's KV. Okay, so this is raw table pairs of values. Okay, does it care? It looks like it just doesn't care. Because it's just T. Okay, so that would mean that it's just right there. But you would need to know the like memory stuff. But presumably that would work. So it looks like it's stored in pairs. Oh. Which is what I was looking for. So then if I wanted to get the key from the value, I would just need to like look at an example of the well, I guess it's like in context as well because there's like um 8 byte alignment. So how would I do that? Probably I'd have some sort of const function. Key offset from value. And then you have to have the type. And then it would do like I don't know how the pointers work. I'm not smart enough. You'd have to go like k minus v, and it would be a negative number. Ice. And you could add that on to the item. So it's possible. Instead of having two hash maps that go back and forwards, it's a bidirectional hash map. You just use pointers. Just use pointers. Huh. I don't even know what the algorithm does, if I'm being honest. Let's see. Scribe Center, I think it's... Like, what the hell is this code doing? It's telling you which goobers were used how much. But, like, does this not, like, pollute ones that were used and then unused? So this goes like that. Indices equals. So it should be the same. It's always 3. Confession. So in this version, I don't care what the usage is and what the indices are, but in the output version, why is it adding dt 0 next t? So it's like okay, now I'm thinking about a different algorithm. Oh no, a super algorithm that uses this internally to locate a space where you don't intersect. Because you could like be well, okay, would that work? need a lot of permutations. I think it could actually work though. So you need a lot of you need a lot of permutations, but I think they could actually work if you push solve and you supply all permutations of surfaces for each object. But it would need to be the Minkowski sum, so it would suck as well. And it's all permutations, which also sucks. Interesting problem. So this is like, what if you teleport somewhere and you teleport inside a coffee mug? Where do you move to get out of the coffee mug? Well, that's a complicated problem. But I think that push solve could be a internal tool. You would really need to cull the permutations really hard if that was gonna work at all, and not become like O of n factorial. Okay, so do I... Does that make any sense? What is up, YouTube? So what is this? Expected. Okay, well, you're not allowed to T. I guess it'd be like K V, and then it would just do that. How would you do this? It'd be like K V. But then it needs to... This is a type. Does that have dot zero? Like, it needs to be... Yeah. I don't know how to do that. I don't know. It's like something like this. Something like this. But this doesn't make any sense. What's up? Oh, yeah, this is just not real. Okay. Did I... Oh, Jesus. Okay, so I think I'm gonna try. I haven't even. This is. I love optimization so much. Yeah, because like if it's not indices, then this gets simpler, and I don't need this structure. And like do those lifetimes work? They must. Okay, so I think I'm gonna do branch. This is fine. Maybe I put this code in a branch as well, because I don't need the output. Okay, so this is. Can I like Poshov? Where is it? Where did I do it? Did I write it at the bottom here? Yeah, I did. Hi. Okay, so I could. I think I will. Ooh, maybe not. Okay, so if I go like this, then it will have the version. So, okay, so this is create branch. What is this called? Push solve output. Geez. Geez. Okay, so I want. Oh my god. Okay, I'll just put this in like my clipboard or something. Let's see. Cool. Code is right there. Okay, so drop. Okay, so I want to delete this. Oh, what did I do? I put a space somewhere. Cool, okay. Go like this. And then now unused function. And then that's like that. And then this goes like this. And then put it back. Yay. Output version. And I'll need to do some stuff to make that work. But I am not going to use it right now. Okay, so now I'm going to rewrite all of this again. So in indices, instead of being an array vec of usize, it's going to be, it's like contacts in use. First time chatter, you're looking through the emojis. Yeah, this is a bad name now. So what is it? Cont refs. I could just call it cons. And then it is a reference to a contact. And this does not exist. And then everybody panic. Okay, you lifetime specifier, how? Oh, okay. Oh, okay. Oh, okay. And then, what's that? Annotating with derived partial ek. Ek. Okay. Ek. So notably, this simplifies things a lot. Everywhere, for everything, for real, for real. So Kiki Kaka is not real and can't hurt you. This is Kiki. Is that it? Okay, and then it's a reference to a contact, and then it's not called I. And then, what happens next? Well, instead of do like this, it does like this. And then instead of do like this, it does like this. And then instead of do like this, same idea. Okay, so that's gonna D this as well, right? Oh, it's not. Okay, cool. Well, I'm gonna just go off that then. Okay, is that it? No, there's one there. Okay. Okay. Nice. Okay, and then... So this is no longer indices. Surely. Okay, so... Yeah. Yeah! Cons. Cont! Right. So then also I need to do index. Right. Any mores? No. Okay. Right. Like that. Lifetimes. Oh my god. Okay. That's very true. Very true. Very true. Interesting. So we do have a little lifetime Goobertonian. I think I can illid this. So this is the XY problem in the rusticles. Rustlings. Rusticulations. Okay, so this has a lifetime, this has a lifetime, and it might include this, it might include that, it might only include one, or it might include none. But thankfully, all the lifetimes are the same. Rusticles. Okay, so am I allowed to just say, hey, be automatic? Yeah. No. What's up? No value for it to be borrowed from. Ah, okay, well. Ah, okay. Okay, well, I guess I'll just annotate them all. Not the biggest deal. I just go like this, and that's it. And just like, okay, okay, gotcha. I understand. Well, that's pretty cool. So this is this, and then this is also and then this is here, and then this is here, and then that's and this is not real. It should all just work. I figured it out in my head. Okay, so this is... Cons. So actually this dies inside the function. Well, okay, the reference. It gets killed. Well, I mean, it does get plumbed through. Plum. Ah ho ho ha 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 ha. I don't know actually. Okay, so this is gonna just find every eye. Okay, so like this. I don't know. How do I do this? Oh my god. Okay, so C. Oh, is that a special thing? Okay, whatever. C. And then instead of CI, none of that happens. It's all just C. And then it's so much shorter. This is the main reason why I wanted to do this, is because this is shorter. Oh. Okay. Okay. So what about... Oh, this is the same! Oh no! C. Okay. C. So this needs a lifetime. What do you want? Okay. What is this? Why? Who said this? Okay, so it borrow value doesn't say where it's borrowed from ba or Baba Booey. What if I told you it's borrowed from both? I think that'll work because these should all have like, I don't know, like, okay, it doesn't actually. Oi. What? Oh. I don't know. So if I do this, I don't know. Unused. Oi, 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 wait, wait, hey. Really? I guess so. Huh. That's an unexpected benefit. Okay, so yes, this was a problem. So I can do like this. Any. Enter. Any. C. And then that's a C. Oh. C. C. Okay, and then STD PTR adder at, and then sorry, and then that does it, right? Oh, okay. So this is like right. Yeah, so I'm gonna call this used. So we don't need I anymore. And then this is, it does this and this, I believe. And then this only needs to live right here. Lifetime specifiers. I'm specifying the lifetime. So this lives through here, and this one doesn't super matter. What? Okay, and then so this is not indices. Okay, rename used const. Cont. Okay, and then this is next cont. Two arguments, but three were specified. What? How did I do that all right? The Bauer checker is happy with this? Do I actually understand lifetimes? That's exactly what's going on right now. But look, this is a reference. It's an array vec of references. It's okay. Well, I am able to like drop the like indices ness by using references. It's a little bit more complicated because of lifetimes, but it's also a simpler algorithm. It's simpler to run because you don't have to index the lists constantly. And like the main benefit is that this is really short right here. That is the main benefit. C, and then this just doesn't matter. I'm gonna take another look at this. So that makes perfect sense. Yeah, so those are all good. This doesn't matter. this has to outlive that. And it does. Oh my god. And then this just does impossible magic. Oh, indices is not real. So magic. It's pretty cool that I thought about that. Direct references are used instead of indices. I am extremely pleased with this. Look at that. I get to drop this like weird spoopy data structure. Bah! Beer! Beer! Bah! Look at how nice it looks. So everything was possible because I figured out this. It's a double. That actually could have broken it, I think. That. If the arguments are thin pointers of the same type, then this is the same as EQ. Pointer EQ. Okay. Compares raw pointers for equality. This is the same as using the equals operator, but less generic. This could be This could be used to compare Babagui by their address rather than comparing the values they point to, which is what the partial Babagui does. When comparing wide pointers, both the address and the metadata are tested for equality. However, note that comparing trait object pointers is unreliable. Pointers to values of the same underlying type can compare in equal. V-tables are duplicated in multiple code gen units. Yes, of course. I don't know what that means. Pointers to values of different underlying type can compare equal, since identical V-tables can be deduplicated. What in the tarnation? Okay, code gen units. So if you, so that's like the compile settings. That's pretty whack. Okay, so what do we say about adder eek? So So this, okay, this compares the addresses, ignoring any metadata. So this is the same. Okay, what's the implementation? I want one that's like, oh my god. Okay, and then the other one. Void. Ain't no way. I think they're both the same, but I don't know what one I should do. So apparently I can literally just do double equals. But I think this is a problem, yeah, because binary operation. Okay. Is this reference the same as that reference? Iter any. So I can't do contains. Where's, oh. Or maybe I can. Probably not. What if I do this? T partial. Wait, did that not work? Okay, what up? Mismatched. Oh, that's what's going on. Okay, I was like, is it actually? No. Oh. Okay. How's it going? I am working with pointers. Okay, so this is So maybe I should call this like all consts or something. And then I can call this consts. Because like that's the type name as well. Consts. Where else? I called it here as well. Okay, so if I do the same, I don't know if that's more or less clear. Super cool though that this function gets smaller, and these ones get simpler, and I get to delete a type. Some crazy stuff. Oh, these are called indices. Oh snap. Okay, so this is where like not being in Lua comes into play here. This is just an empty. Ouch. Look at how nice that is. This is not nice. It is unreachable because this has a maximum length of 4. So you have 4, 3, 2, 1, and 0 elements. This is not a possible thing, but I guess this can't hit the compiler. How about that? Unfortunate. Iter. It's a reference to an array vec of references. We're like, this is like Rust is coming through here because like there's definitely some like lifetime nitpicks to be had here to like say yes, this value lives the same as this value lives the same as this value lives the same as this value, which is merged into the outputs. And like this could be less than 3, so it passes 3 in here, but it could be less. The code got simpler and more complicated. Gosh. Factor out indices. Use only direct references. Minus 78 points. No, it's a golf score. What an interesting idea. What size is this? 40. Cool. So it's got an 8-bit U size that represents what's the size of the list, and 4 values, which are all or bit. I mean byte. 4 values which are all 8 bytes. So that is 5 times 8. That is a tiny type. Let's go. Everything is like compile time. Yeah, everything just lives in compile time and then it just vanishes for the actual execution. I also want to credit Trey. So this algorithm is based on an algorithm capital A written by Trey Reynolds in what, 2018? Is it 20? It's probably 2019. We can actually see okay. $2021. Did I not have this until 2021? He's streaming, silent stream. Nice. Oh. Oh, this is adding it. So I added the code to the game in 2021, so probably he wrote it. It is based on code. I think I want it here. Pretty crazy algorithm change. Holy smokes! Completely factor out the idea of array indices. The usage of array indices, and only pass around references. Insane stuff. That was a nice transformation. It just got more rusty. This is like my two favorite parts. I actually said that. My two favorite parts of this refactor are the deletion of this struct and the crunching of these things, because like this was like a like data structure to try to like mimic the Lua, but now I thought about it more deeply and it's better, stronger, faster, rusty. Cool. Who knows if it works? I don't know. What? 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 So there's still a problem to generate the data used by this algorithm. Generate and maintain. I do believe I can still. So like I might not be able to. In the best and fastest version of the code. Well, I guess I can't actually say that. In a version of the code that is better than this, I may want to have a hash map of collision to contact that contains this information, and then I can use a iterator over hash map values instead of a vec of contacts. Like basically I'd have to generate this list every time I want to call the push solve function, and that's slow and bad, and don't do that. How much heap allocation am I doing? For real. I feel like I don't do a lot during the running of the physics, and it's mostly like just like looking at stuff. So like yeah, so when I am loading the graphics, I know I do a bunch of heap allocation, but that's like loading. It's so cool. I love Rust. The distinction between heap allocation and everything, stack allocation, knowing about that, like being presented with that information rather than it being hidden behind an interpreter wall, and being able to think deeply about my algorithms and data structures and everything. It's very, very blissful. Generate model. So this is like loading. So do I ever collect? So this is loading. So this is not the same thing. The Minkowski, yes. Okay, so the Minkowskis do heap allocation internally. Unlucky. Because I couldn't figure out how to do a reference. Because it would need to like recalculate things too many times. So, I mean, this isn't doing heap allocation directly. It's only indirectly. Oh, I also deleted the heap allocation from the zeros, which is excellent. That was bad. This is pretty tight loop. I wonder if I can delete it from here. So some places here in the Mike Wazowski. Which one's EV? Oh, I see. Oh yeah, the insane algorithms. Gosh. Iter, enumerate, return. Okay. Fev. So where's the one that's the cow? Oh, is that somewhere else? Oh yeah, that's in the mesh query. So you got cow. So this is doing collect. Iter map. Owned. Like, it's not the craziest thing. This is a little bit crazy. Yeah, so this would be a region for some micro optimization. Because now the algorithm exists and mostly works. So now it can be made better. Huh. Very neat. Very, very neat. This is kind of a window into the optimizations of the algorithm. It gets affected by the changes. Oh my goodness. Very, very, very satisfying. Everything got smaller. How can I like see the size of the file? Like, I swear this reduced the size of the file. Probably by like a kilobyte or something. Maybe not. Maybe half a kilobyte. Let's see. Disk usage. Source. Push solve. 12 kilobytes. No way. Exactly 12 something or others. Okay, I don't care anymore. Wait, what is this? Oh, this is me looking at the hash set. Okay, now I actually have to implement this in the code. I have to like use it. Nar. Point. Could I just use 0? Then I would definitely have to recalculate them. But like in here it's doing like this minus point. So that's basically plumbed into there. Okay, but then there's all this stuff. Where is it? This. Point plus solve relative to point. So if they're already relative to point, does that make any sense? I don't know. Ideal point. That'd be so cool to have like Euclidean point and ideal point as like distinct types, and no one knows what that means, and that causes a bunch of type errors, type conversions. This happens a lot where I get mesmerized by my changes in my code. Oh. Oh, it's right there. Any is better. I don't want to implement. Okay, so basically it shows up in a lot of places, like 3+. Yeah, so it's this. It's the proper algorithm for this. Constrain velocity. Yeah, this as well. To do tray push solve. Ayo. Is this chat? Is this real? No longer to do. So the problem is it's not in the right format. So contacts. So I could get the contact normal. Wow! But I can't get the. Oh my god. Makes a whole ass Minkowski sum. Like this doesn't actually do any work. It's just a pair of transformed meshes. But it looks kind of crazy. And like this is also really simple. This is also really simple. This is perhaps also really simple. So yeah. Why isn't it const? There's no mutation. Contact mesh. Ah, it's doing like stuff. New. Const. Submesh view. Ah, submeshes. pain. Is this const? No. Slice from ref. Gosh, I am a crazy person. Silly goose. I got lost. Never used. Huh. Ah. Ah. Minkowski. Is that even possible? Face ND. Face ND. ND. So the D would. Oh, right. Oh my god, I want to do a whole bunch of stuff to make it relative as well. That's true. Oh my god, I'm remembering stuff I want to do with the physics engine. All makes sense. Rah. Okay, so what if I just... So what is the D value? The D value is like... You multiply it, right? And then that's it. And that's the point. Yeah, it's bad because it's in like absolute position, and so you can have like giant numbers go through the algorithm, and that's not the best for a fixed point. In fact, it's quite bad. Face ND. A little bit crazy. Kind of freaky. This is definitely freaky. Do you just multiply it? I totally forget. Oh, yo. I could turn this thing into an iterator. This looks like Lua code. So I can use min by key, and it does this. Best edge. Map or. Real? Jesus. My. So I have to iter. Filter map. Yeah. This isn't very comfortable. Iter. Filter. Yeah. And then min by key. It can be dropped. So I could do that, but meh. I don't even know if it would be better. Gosh. Okay, so face ND. This indexes into the normals. So I think that all I need to do is return both of these values, the n value and the d value, and multiply n by d. But I'm not 100% on that one. That's the only spot. Interesting. So every single reference of this does that. With length. Would that work? I guess I have to try. Okay. Oh, whoops. I'm gonna need to do a little bit better than that. How many references? A few. D. Hmm. Yeah. Oops. This is just like a thin wrapper around this function. Did you see the new Roblox client for Linux? It's not open source, so I'm not going to touch it. But yes, I did see it. And it sounds like it's working well for a lot of people. So cool. But Roblox is like where all my money comes from, so yeah. If they just suddenly decide to flip a switch and steal everyone's Robux, then nothing you can do. And there's no way to know. I don't. Is this the right way to do this? Shouldn't it be like this? So then this one is inlined inside this function. But I only want this to not be a function call. I don't know, man. Okay, so I don't know. Does that make sense? No. Doesn't super matter. Like, the compiler will probably recognize this and be like, that is very little function. Okay. Why don't I write a naive implementation? And then we can go from there. Okay. So, no longer to do. Map. contact collision. So we go like position is n times d, as much as I hate it. The velocity is n. The normal is n. Would you believe it? And then push solve, push solve. Contacts, point is velocity. Okay. That should be it, pretty much. So that is it. And it returns an optional value. So it could possibly fail. Question mark. Okay. Bruh. Huh? Oh, it wants a frickin'. Oh my god, bruh. What do you want? Oh, jeez. Okay, so that's like how I think it works. So now the math is even worse. Like this, I think I actually had to do this to get it to not destroy itself. And now it's even worse. Okay, velocity. I forgot. No. 0. In it? How the hell does this code work? Position normal normal. Velocity normal normal. Velocity at point. So this is positions. So I was wrong. So I don't actually need the d value right now. Zero. Okay. I do believe that is what is up. So apparently I don't need it still. Cool. Should I just silently fail? What happens if the algorithm fails? Wait, it's dumped. It does silently fail already. Match. Okay, and then none of that. Get out of here. We silently fail around here. Okay, and then this one as well. Why is it doing like that? Yar. And then the difference is acceleration. So easy. Yeah. That ought to do it. ArrayVec. Oh, I see. Those things also depend on ArrayVec. Oh, that's cool. I think the game is going to crash almost instantly. It might freeze in an infinite loop or divide by 0 or something. It's kind of a sidelined algorithm. So as long as I got the basic thing right, it should just work. Algorithm silently failing. Smiley face. That worked better than I thought. So I need to debug it. Yeah. Implement push solve. So actually I don't need this yet. So algorithm is silently failing, and I have no idea what's going on. Right. So should I go in and add errors? I don't think I'd be psyched about multi-level errors. I mean, it would tell me what went wrong. Divide by 0, where IZ vec2. Wait, what? Vec2? Vec2? So the algorithm failed on a very simple case. So probably there's some parity issue somewhere, somehow. The way to figure this out is to pass the same values to both algorithms and watch them run through. Can I do that yet? Yes, let's do it. Push. Oh, I need a goddamn vector. Can I like enable Lua vector? Compile? What in the tarnation? I was wondering if I could like enable vector 3. Oh. Yeah. I might honestly just be able to run a test on this one. How the hell does this work? I forgot. Tests. Looks like it doesn't matter. Neat. Right. And then push solve. Yep. And then I guess should be like this. I think like that. Let's give it a gander. What's up? Oh, yeah, sure, whatever. Okay, cargo test. Tests. Test. I should probably call it push solve. Did that actually work? Failed. It failed. Okay. Neat. Okay, so now the code runs once. And I can print things as they happen. So, I don't know. So, let's just get an idea of what's going on here. Where is it failing? I should probably do like this, I guess, because this can also return. Return. And then here, I guess. Okay, let's see. 1, 2, 3, 4, 2. Okay, so it actually got through an entire loop. And then started again, and then this died. Okay. So then died. So this returned none. Oh. Next T, next I. What? Infinity. So I think I see what's up. I need to do a match here instead of a exit. Because like if there's no, I think this function is working correctly, but if there's no ignored Goombas, then first I is nil, and that is allowed. First T is infinity. Whoa. So that goes, next T is greater than 0, and it returns. Okay. So I guess I can control flow that. So we can do equals match sum T const. This is a tuple. Just like this. None is return. Pass the test. So what it did before is it returned infinity, and that was greater than 0, and so it just returned. So I could mash this in here, but whoa. Eh. Okay. Well, build it, I guess. I do believe. Test. Okay. Oops. No! Why is it running so many loops? Isn't there like one freaking goon in there? Wow. Ha. Ugh. What? Why is it running so many loops? Oh, it's separate. Oh. Okay, so chances are the math is hideously imprecise and you're like slightly flying or something. One, two, one, two. Oh. So what we're looking for here is angled surfaces. Oh, the lag. So we can do that. Ooh. So the reason it's not doing the same thing is because I'm not walking. Walking is bad. Okay, so right here, I can hit this corner, and hopefully it just works. Not quite. That worked. Kind of. Maybe. Kind of looks like it's working. Nice. Okay. So we have a semblance of working. The real treat comes with like the thousands of touching surfaces. Thousands is completely wrong. It's usually like 2 max. Most often 0, of course, because they're in the air. And then second most often 1 as you jump on the ground. And then rarely 2. But with edge cases, but like you can hit up to 3. It's not crashing. I mean, clearly I fixed that one case. I need like a playpen of like horrible physics cases. I might be able to like find a map like that. I look hard at the old stuff. Take a while to find though. Oh, that's right, it doesn't work. So why doesn't the walking work? Is it like... It has to be calling the function. Set velocity. Call... No, it's doing... Constrain velocity. Constrain acceleration. Wait, is it an accident? Is it culling the ground and you're standing on nothing? Could very well be. Oh, that's a case, that's a case. No, don't do that. I need to test this. So if I can just like surf into a... Oh, this might actually be working here. Oh, nice. That was working. Like straight up that was working. Okay, that's not working. Why can't I surf on this? What? Why can't I surf on this? Okay, I don't know why I can't surf on that, but I was looking forward to that test case. Okay, is there any other angular... How about... Let's go to Surf Memorial. It might be this one. Run. Damn. Okay. Is it gonna work? Maybe. I don't know. Maybe. Is the Rust algorithm conversion finished? It was finished yesterday. Is Roblox your only source of income? Well, technically no, but effectively yes. Like Twitch, I get $70 every 3 months or something. I used to get that from YouTube as well, but YouTube like banned me from getting money. Oh, okay. So surely, okay. So it's right there. Okay, so what if we just do this? I expect this to not work. What? Wow, that worked. That was the algorithm working. So this is something else. When I fall through the ground. Okay, it's not falling through the ground. Okay, is that even real? Wow. To switch to Twitch? I am still streaming on YouTube. Huh. So, clearly it's not perfect. But it's working. Okay, I gotta look at why it's calling the algorithm when you move your mouse. As probably the call velocity business here. Set velocity call. Set velocity. Constrain velocity. How would that be any different? It should just be the same thing. Confused. Okay, what? Did it return non-zero? So you're fine until you're not fine. It didn't happen. Set velocity call contact. Whose call is that? Why would that be different? What? That's not this. That's not the right part. That's not the part that affects that. Okay, so it was way easier to implement this than I thought. Oh. Broken pipe? Huh. Okay. So it's not doing this anymore, which is neat. Do I need to unitize it? What if I just do that? Oh, Jesus. Physics issue. I guess. More like new feature, and the whole thing is just ungood. Okay, so fine, and then not fine. Okay, so that didn't help. Fall through anything. That's a new one. So it made me start touching it, but it didn't clip my velocity, but it did clip my acceleration. No. So I started walking up. That looks like a walk. Oh my goodness. This is a big part. As long as I stay jumping, I'm immune to these problems. Oh, jeez. What I don't understand is why this affects falling through the ground when you move your mouse. That is whack. Like, is it just like magically? Okay. Shh. Is it just like in? Okay, that's not very nice. Okay, what about this? This is a very easy case. The old algorithm would have handled this. I want more like test cases like this. So the maps that I was using are very rectangular. What if we go here? So, can I escape through this corner? What if I go up here and just go like, Wah. There's a trigger there? That is awful. Why is there a trigger there? Horrible. So I can get through there. Haha. Wow. So like there's problems. I don't know why. Why does it look like? So there's like numerous issues at play here. So it's kind of difficult to isolate one of them. This thing is very fragile. It's been in this like fragile equilibrium of like everything. A lot of things seem to work for many months. I need like a place where there's not a freaking trigger. How about right there? Can I hit this? Not very successfully. What about like this? Oh, that worked well. So that's what the algorithm is for. Is it's like preventing you from moving when you hit this corner. So it seems like the algorithm is working, but it's running when it maybe shouldn't be, and exposing something else that was a problem that magically didn't matter or something like that, with like the wrong code giving something that made it work. Really what I need to do is get rid of all of the set velocity calls. That is a awful function that should not exist in the physics at all. Is that an algorithm failure? No, it just set velocity call. What? Okay, it must be because the normals are like I guess like the normal it gives is slightly different than the surface normal. Yeah. Well, but it doesn't give a normal. I see. The velocity call do. It sets your velocity and then removes all surfaces that you're moving away from all in one go. But that's like implicit, and it needs to be explicit. Okay, so I think what's going on is the precision is murdering the stupid implementation. So it's imprecise, and so it's like doing things to the velocity and then it ends up with the same value, but it's not exactly the same value. And then it is not exactly perpendicular to the surface normal. And then you fall through the surf because it thinks you're moving away from it. And then that frees your acceleration. So it's like cascading precision effects. How did any of this ever work? Like it was all just a house of cards. It's so tough to like keep this like working. Is that a 90-degree angle? So hard to tell. Okay. What about like this? Okay, that's not actually a real case. I mean, it is kind of. Because like that's the bottom of your hitbox, so it's kind of different. Only when you turn your mouse? I need shift to boost. This is so slow. Man. Wrote the whole algorithm and the imprecision breaks my other code. But that kind of reveals the house of cards. Interesting. So it works quite well when I'm not moving the mouse. But that is not touching multiple surfaces. And this is like still like 90 degrees. Ay, 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 ay. As soon as I go beep, I'm floating inside. So there's something about moving the mouse. It is doing cull velocity. Oh. I don't know why that happened. I mean, the algorithm is like working-ish. It's just indistinguishable from other issues. So I don't know if there's multiple things failing. It's really tough. It's kind of demotivating. This didn't seem to change anything. Yeah. Right. The other thing was the timer UI. The scale of the project is like getting to me. Ugh. If only I didn't run out of money, I would have stayed at 100% passion. Now I'm like worried about running out of money, even though I'm not going to for another year. It doesn't make sense. This is like, this doesn't make money. I want to do so many like little rewrites, but it's all okay. Okay, is there a Rust fixed point vector? Yeah, that sucks. 3. Fix the length. Bruh. T. Dot. Is this some real stuff? No. Or is it done? How's that? Low. How is that? Muscle lib am. Math. Bruh. You're gonna see Rust I click. Same. So I'm gonna enable the non-broken version of the game engine. Then we can see the coolness without the new feature that breaks everything. Waiting. Whoa. 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 Oh my god, it's a Rust game engine. So cool. But actually, ugh. So I added a new feature to implement an algorithm written by a friend of mine that I was using in a previous version of the game. Oh, I missed. As in a different programming language, previous version of the game. And so I translated the algorithm to Rust. Oh, damn. And it broke the whole thing. The whole thing was made out of thin sticks, and it was like a bunch of bugs in a pile that looks like features. And like, of course there was bugs, but like, look, you can jump on the squares. But like, if I try for a second, like that's a bug. Oh, the walls are strong today. Oh, there we go. Yep. So you can just break it if you try. And that's not what I was fixing. What I was fixing is when you touch multiple surfaces, you need to do like linear algebra and like determinants and stuff. Determinants to determine if you're allowed to move in a specific direction depending on like which surfaces you're touching. And it seems like maybe the algorithm works. It definitely worked in the previous version of the game, but it's exposed problems everywhere else. And like the whole, wow, look at the game, it works stuff is a little bit less oh damn, a little bit less it looks like it works less now. Oh, come on. But like it was never really bulletproof. So it just like is less playable. It's a really important algorithm for like closing out cases. But like, am I gonna need corrections? Like every other physics algorithm out there. So the cases where you touch more than one thing at once are very rare unless you try to do it. So like if you touch a wall like this, that's perpendicular, so that's like easy. But when they're not perpendicular, it restricts your movement in a way that is not easy to calculate. Reminds me of surf. Well, we can do that too. Ta-da! Oops. Yeah, there's problems. Haven't figured that one out yet. It used to not do this, but it was in an older version of the physics engine that was worse in other ways. Ah, jeez, didn't make it over the freaking thing. Come on, work around the bugs. What? I didn't launch. That's what I expected to happen. Yeah, I saw that coming. Tried to go over top of it. There's like bugged places everywhere. Oh, it used to work better, but it was worse. Oh, it's so hard to make it all better. Little tiny edge cases. So this is the algorithm that I ported. So it was in Lua. And now it is in Rust. And I'm very happy with how it turned out. I was not really looking forward to doing it, but I think I did a good job. The only issue is that at the lowest level of like the linear algebra solvers are using fixed point arithmetic, and it's like deleting precision every time you do a multiply. So cross dot, and then it's dividing by an imprecise number. So it's really imprecise, and that's actually showing up in the game as other bugs. So I think the algorithm works. What I would like is to have fixed point vectors that can go beyond 128. Is that a? That's a tab. 128 bits, and I can have like 512 bit integers, just so I can do this entire thing in one go, and then divide a 512-bit integer by another 512-bit integer, and get the answer. How slow is division? Division is O n squared, isn't it? Buh. So another way I could change things is to try to get the best of both worlds and have integers for absolute coordinates, so like position. And then when you take the difference of two positions, well, now suddenly you get a floating point number, and then I can do simple, lazy linear algebra and divide things and multiply things and not care. And then if you add that onto a position, well, you just get a new integer position, and it like does the type conversion when you go from a Euclidean point to an ideal point, which is like a difference between 2 points. And I think that's the greasy way, the way that like there will definitely be like I wanted to avoid floating point numbers entirely because like CPUs do it differently. And like the game is all about simulation replays. So like if your CPU does floating point numbers differently, then you won't get the same result of the simulation. But everyone agrees on integers, because like, what are you gonna do? Get the wrong answer? Ugh, but my simple basic integer types are reaching their limits, mostly because there's not enough precision, really, to handle multiplying two numbers and then multiplying again and then multiplying again and then dividing. It's like putting off the division until the last step. Yeah. I don't think there's anything crypto. What crypto? Big int. Can I do crypto big int? A crypto big int backed fixed point vector. And then it steps up. I don't know. It sounds slow. Sausage. Ooh, gross. Oh, jeez. I'll be right back. Do we really need nanometers? Yes. We have computers. Give me the nanometers. Oh my god. So, what the hell? I guess I can just make a thing. Dot products, cost price, linear order, right? Some hello? Okay. Cool. Okay. Okay. Fixed. Crypto big int. Extra sizes. What is that? I think this is the one that I was looked at before. Wait. Bad crypto. Wait, it's just using someone else? Hold up. Wait a second. I thought that was like the good one. Integer trait and functions. What does this do? Oh, is this like shift left and stuff for stuff that's not primitives? Bart. Vestigial. Okay, what is going on here? Lib. Div floor. Okay, so this is like, whoa, you got numbers and you want stuff. Check simple. Okay, so this is not the big one. Where is this? Okay, so num big int, is that literally they're just using someone else's, or is that like for variable size? Because like I don't want variable size. That's for true. Vector. Okay, yeah. Okay, so this is like, wait, dev. Oh, that's a test. I knew it. Holy, look at that. Okay. Optional. What features? Rand. SDD. Okay, so I did remember correctly. Yeah, it's cool, cool, cool. Okay, so I don't need random numbers. No features. I don't know. How do I do that? Default. Something like that. Oh, snap. Okay. What the hell happened? Okay, so I'm over here. This is here. Look at that. Okay, so... false. Yay. Okay. So then we got the fixed man. So I need... So either I need to make a vector, which I already did, and it's like mega basic. But like I was also basing it off glam. Because I wanted like... I think this one is more generic, but probably still not generic enough for my stupid use case. What in incarnation? Holy. Oh! You can just straight up do that. Holy! I was wondering how you do this. You can just depend on multiple versions. That's crazy. So I could totally do that too. That's so cool. So I don't need to have like different entire packages. I can just have like, I'm thinking about like the map file format and the bot file format. If I implement a new version of the format, I still need to support the old version. So I just like gain a dependency and I like convert it like this. Cool. What? Really? Yeah, this is super bloated. Insane. All features was true. Wait. What is it? Yeah, bruh. Default macros. I don't even think it does. So matrix multiply. So I think it's like variable size. So like you can have any size vector. I don't need that. So this is like if you want to do giga math and you just use floats. It might also keywords. No way. Fixed point linear algebra. I want to have two options when I multiply. I want to have an option to drop the precision or to extend the precision. What are you focusing on now? I am kind of lost, to be honest. I want to like polish out a 1.0 for the game, but of course I have very high standards. So the features would have to include loading maps, which already works, physics that mostly doesn't suck, which it kind of is there I'd be okay with having it as is. It'd be better to fix more bugs. Definitely the falling through surfs bug must be fixed. There's no way I can release a 1.0 where you can't surf. And then you must be able to replay bots. So that's like my requirements. I'm trying to be as loose as possible. What I want is a coherent single player experience, and release that, and then start working on multiplayer. But the project scope is just, there's so many different things to think about. There's so many little bugs I want to fix. There's so many things I want to make. There's like I said, it's not even touching the infrastructure back end of like a database of bots and rerunning the bots and like I stick. Excuse me. I say it's a 5-year project, and I was like ready for that when I started it. When I started working on it, and I worked on it for 6 months, and then I ran out of money, and that messed with my brain because I haven't ran out of money before, and so I don't have the same passion as I did when I started. What the hell? I didn't want to go here. So when I came back to this, like 2 months ago, I started working on it again because I solved the money miraculously. I dove right in. I'm like, yeah, we got to get back in here, and I made map files. I expected that to take like 2 months. It took a week. And I made bot files. I expected that to take 2 months. It took a week. And so I kind of ran out of big stuff to like delay having to make a bunch of new features and like toying with things. Because like if it took 4 months to do that, then I would probably have like processed more things that I want to do and have a better idea of what to put together. So like I just spent like an entire evening pacing around my bedroom, like thinking, what should I put in the 1.0? What should the plan be after that? What should I do this? And yeah, the project, there's just so much to think about, and it's so much to keep track of. Right now I'm looking into a massive tangent of rewriting the fixed point mathematics, the fixed point linear algebra that I'm using, because it sucks and it needs to be wider, or it needs to use floating point numbers like everybody else. And I have very specific requirements for the fixed point linear algebra that does not exist in anyone else's libraries. So I'm like making a toy here, a toy library, which might turn into a real library. And I'm like just looking at the dependencies and stuff, and I'm just gonna play with fixed point numbers. Is this a new project? Modifying the way the project works. It's a toy project to try to experiment with new ways of doing the same thing that could solve some fundamental issues I'm running into. So the biggest problem is I don't have multiple fixed point types. So I can't say this number is this precision, and when you multiply it by this number, you get this precision. There's one type. Should I do tests? I think this is alright. Mm-hmm. So let's see. Pub function. I should leave it. Fixed. So it's a one of these with a something else. Frack. How the hell do you do this? Fixed types, okay. Okay, so it'll be like type equals this, and this is the same as what I was doing before. And gives the same result. And then wide one. I don't know. So that's like you multiplied once or something. And then it's 128 and 64. So then that's all well and good. Gimme tabs, goddamn. Please tab. Yay. There we go. Okay, so then add does that. Mul drop. What is it doing? It's like drop the precision. Discard. I don't know. Discord. So that gives the same width. And then mul extend. I should definitely change the wording, but wide. It makes a wide number. Oh, look at that. Same language. Ho-ho! Yahoo! Okay. Holy smokes. Is this const? Let's go. Okay. What do you want? Frack. What do you want? I thought that you were supposed to do like... Is it like frack? Dude, I don't know. What the hell is a frack? What? Type alias U32 is private. Generated consts. Types extra. Are you for real? Is this real? Okay. So you should be able to do this into. It might want try into. Nope. Okay. So that's gonna be a compiler error, isn't it? Or not? Cargo test. Oh, I see. You're allowed to compare. Cool. Cool. So, okay, what about wide? So I like this way better. Wide. Wide mul. I guess, sure. I'll just copy these names because they're good. And this is mul normal. Making sense. So the trouble is, this is where it tops out. That's one multiplication, and then we're done. I need 3. So I need to double it, double it. So, need to do that again. So wide mul is already in existence, and I don't need to do anything about it. Yeah. Wait, do they have goons like this? Okay, whatever. So this looks stupid, but it should just be compile time stuff. It might make compiling slower or something. Goodness gracious. B1. Boy. Zero 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 001. I'm assuming that's um 000001. That's 32. Oh, it doesn't freaking say. 32. Well, that's stupid. But you need to represent it somehow. I wonder why they didn't go with just a type for each. Oh, I see. Huh. I see. I understand it. So that when you multiply, it can do like algorithmic type manipulation, constant compile time, type logic to determine what width it should have. So like if you have 5 bits of precision on your left hand side and you multiply by 7 bits of precision on your fractional part, not precision. So like you could have 32 bits of precision with 5 bits of fractional precision. So you have like variable fractional precision, and then it's like, what's the result of that? Where does the fractional precision end up? Well, it can do that at compile time, and all of the logic goes away when it compiles. So that's what's going on here. It's for convenience, implementation convenience. True, false. Create bit. New. Wow. Public struct. Representing this bit. Oi. False and not bool? Oh. Wait. Why wouldn't you do this? Isn't that cooler? It's duplicated code. Why isn't it const? I guess it doesn't. I don't know. Don't tell me this isn't compile time. Don't tell me this is like this for no reason. It keeps going! What is that? Hey, yo! Oh no. Boy. Oh my god. Does this actually cover insanity? Does this have type num? Does this have big ass goobers? What I guess let's check it out. Wide 2, no. Extra U1 like so this would be convenient if they had this. That would be convenient. 512 256 done. I would use that instantly. But they don't. Oops. That's 3. Oh. Hold up the phone. Do I only need... I'm thinking of Zig right now. Zig has variable size integer types. So... Take me to it. What? Oh. Macros no frac. Mm-hmm. Boy. This is like insane. Oy, 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 oy. So it'd be nice to have like little SIMD is cool. I can't use SIMD. No. Sorry. Okay, what is going on? I'm gonna clear these dishes. I'll be right back. Ouch. I need to munch. Munch on something munchable. Crunch on something crunchable. Is it possible to get unbanned? You need to talk to the moderators. They are the ones who manage the Discord. I'm not even the owner of the Discord. How if I can't join? Is there any mods in the chat? Is this? Oh, okay. So it can only be the exact same. I was wondering if that makes sense. If I was wondering if this was the case. Cool. Easy clap. Okay. So it drops frac bits of precision every time you multiply. So then what about wide mul 2? What? Oh, what? Ooh. Okay. Okay, so they want you. That sucks. Okay. So I need to sign bit myself. What's the point? Oh. This is variable size. Think I'm cooked? I think you just need to contact a mod. Let's see, what can I do? What's your Roblox username? Okay, I said Roblox user is expressing interest from being unbanned. No sign. Jesus. Yeah, this is general. I don't want it. Fixed size. Big int. Four years ago. Oy. Uint. But I don't want uint. Do the sign for me. Oh my god, bro. Okay, that's actually an interesting point. You accumulate a sign bit every time you multiply. So you have like 3 spare bits or something if you multiply 3 times. Or 2 spare bits, I guess. You still need the sign. Huh. I'm thinking. I'm out here thinking. Oh wait. Okay. What is this? I don't know, man. Sure. Man, I just want like a main function. Can I just do this? Bin target. I don't know how this works, man. I just wanted to print. It can't be a test. Oh. Like there's a way to like no capture. I don't remember it. Cool. I guessed it. So there it is. There's 2 different numbers. So yeah, you get an extra bit. So does that mean in this stuff what is this called? What the hell happened? Oh, here. So this thing, Radicand. So what do we got? We've got 2 64-bit integers that are casting to 128. So when you do that, you have 63 bits of doobly-doo and then 1 bit of sine. And then when you multiply them together, you've got 63 times 2, which is, I assume, 126. 120, yeah, it's 126 bits of doobly-doo. And then 2 spare bits, well, 1 spare bit and 1 sine bit. So, okay, this is multiplying by 4, so it can actually be too big to fit back into a 64-bit int. If this is just magically worst possible case. Which I have yet to see. But maybe it just silently fails. Okay, continue on my floating point adventures, or fixed point. Rest fixed width signed integers. Arbitrary? 5 months ago, not bad. Oh. It's like S. Not what I'm going for. Wait. And then they go and do this? Like what? Okay, what does this look like? How crazy is this? Oof. So these ones make sense. And then optional. Oh, they're all optional. Oh, fantastic. Okay. Default is nothing. Sweet. Okay. 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 Cool. Okay, what does it look like when you do it? Boing, boing. Okay. Ops. I got ops. And what? Okay, where does this? Okay, I can just add it. Bint. Bogus binted. Okay. Bint. Bint. Is it like this? Bounded integer. What? Wait, is this something else? Oh, it is. Oops. Bint. Semicolon. Sure thing, brother. NU size. Oh, jeez. Okay. Types. A. What is it? 224? 192. I forget. Screw it. Oh, it is 192. Okay. Well, that's fine. So then, does it need to multiply again? I think I said yes. G. Bouet. Bouet. What? Bouet. Fixed size, which must be known at compile time. So is it literally just adding? Is it doing const that way? That'd be pretty neat. Nice. Ah. Wow, double bot. Nice. Twitch going crazy. Fruit fly. Mm-hmm. I wonder if I can use the nutty macros from the fixed crate and like have my own fork that uses these for the big guns. That would be helpful. graph. What the tarnation? IZ. 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 So this is what they want you to use, which understandable. Get. Inner. Int. Bart. What the hell? What is that? Is that fused multiply add? That wouldn't be good for fixed. Okay, who knows what that is? Oh. How do I get it? Two bits. Hey. Real? Who knows? Okay. I'm guessing you can't do this. Yeah. Non-primitive cast. Okay, so it'd have to be this from or something. Bits. Boo. I see. Okay, so that's not real. So we probably want like from. Okay. Mismatch closing delimiter. Pog. Real? Is this real? It is real. Okay. Sure. So it'll be something like that, but better, of course. course. Cause like this doesn't know the frac. Or maybe, is that fine? I don't know. Because there's also the case where you have 3 multiplies, but they're all small multiplies. And that needs to be represented like this, but it has fewer fractional bits. So that's where the Benum backing would come in. Hi, good luck. What does that mean? Scoobly doobly. What? Holy moly. What is total ordering? Is that what I was thinking about a few days ago? What is this? X, is that XOR? So it's flip all bits except the sign bit. Why wouldn't you just flip the sign bit? I guess it's the same amount of work for the computer. It's like 2's complement or something. -1. Compare. I see. Okay, yeah. I was thinking about this. Like, if you put the exponent in a certain place, you can, like, kind of make sure, but also... No, you can. Yeah, you can. Have a total order. Cool. That is what I was thinking about a couple days ago. Neat. I didn't know this was in here. Why is there 120-bit floats in here? Ugh. God, should I just have like an error on every single math? Because that way I can match it. And I can also like clamp. So I could say it's an overflow, it's an underflow. To divide by 0, something like that. So what is that? Is there like checked division? Yes, there is. And what does that give? Option. So that's divide by 0, right? Who knows? But that's neat. Oh. As long as everything is done at compile time, I'm happy. Does that mean I can use check div for the other bits? Hold on. Because that's like what I'm doing. Right? Oh, epsilon. Bruh. Oh, right. I don't have that on my stupid class. Oh my god. Imagine if I could use like 5 bits of precision and it was just excellent. It's just like so much precision. No one ever needs any more precision than that. And then wider, 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 and it's fine. It all fits in 128 just fine. But no. I wonder how few bits of precision I could get away with in the world positions. Maybe 8 bits. But then it wouldn't be nanometers. It wouldn't be cool. Nanometers. Nanoseconds. Pain. So what I'm thinking here, instead of cross and dot, it'll be wide cross and wide dot. And so it'll take these types and put them into a widened version. But I need vectors. I need the like fractional location and stuff. And I don't have that. So like one layer isn't that bad. 2 layers, pretty bad. If I do wide, then I can clamp it after. And I can also like check to see if it's in that clamped range. Yeah, I think the tools at my disposal are just insufficient, and the laying division is more appealing than floats. Hmm. If I can successfully delay all divisions, look at the macro again. What the hell? Is that a real thing? Can you actually do that? No. What? Oh, did it crash? Looks like it crashed. Wait, what? Oh, there's no cursor. Oh, okay. Divided by 5. This is basically what I want. This is just, if I could just use this library with wider fixed width integers, I would do it. Okay, what happens if you keep going? Wide. Mall. Yeah, there is no more. You can't. So 128 doesn't have wide mall. What would be great is if I could just expose everything from the inner type. And then have a single overwrite. Where's it? My parents are coming back after a vacation. I'm gonna visit my place, so I'm gonna stop the stream and clean out the garbage and probably vacuum and stuff. It's a good opportunity to clean up. This is gonna take a lot of thinking and possibly a lot of effort to get these super wide numbers. What I was doing before with the integer types was I was just sort of minimally implementing just what I needed. I think that that could be a strat here. I could have like fairly, fairly real logic underneath that is using these numbers from the fixed library, and then when I want to go wider, I I have more types with like the bint benum. So I started out with Glam, the library Glam, with the floating point vectors because like I'm making something from scratch, whatever floating point, and then I rewrote the whole thing with integers. And Glam is not that glamorous for that. Haha. But I do need Glam for the graphics. Maybe not. We'll see. I might be able to drop it as a dependency. And then use fixed mainly with my little goober vectors. And then do wide, checked division, and then have clamp operations. The number of issues is too high for Rust. So I gotta like restrict what's going on, put some errors in, handle the errors, and then we're back to being rusty. This is gonna take a long time. But it's a fundamental issue, limitation, running into a wall, and that wall is precision. Yeah, like floating point would do a lot. After the division, but like, don't tell me, is there F128? There's no way, right? Sad. Wait. For real? Unused variable. Hold up. Wait. Is this real? F120 is a thing? Oh. Wait. Should I just use that instead? Because that will cover the entire 64 bits. Very, very new. Really? So, with this, I would start with ints, convert everything to float 128, multiply, divide, blah, 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 then clamp. Honestly, float 64 is probably pretty good, but then, like, yeah, floats is using floats-ish, kind of. Like, as long as it's not subnormal. I don't know, man. Oi, 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 oi. Baba boy. F-128 is really funny. But it's like pushing the problem back, kind of. It would probably work. That's a big float. How many bits is that sucker? Nightly only. Ayo. Is it gonna complain? What even CPUs have this? No platforms have hardware support. Oh! Oh, okay. Increase precision by using twice as many bits. That's not quite correct. The sign bit, actually you don't need two of them. So you get an extra bit of precision for free. Okay. Hmm. 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 Yeah. So, I mean, even if it did exist, I think that it wouldn't be a good option. My personal favorite is probably I could make a tier list of the precision solutions. So probably my first favorite would be wide integers. So I'll use 512-bit integers for certain operations. Then the second best and probably faster would be to make a distinction between Euclidean points and ideal points, where when you subtract two world positions, it becomes an offset in floating points. So the world positions are integers. Then when you take the difference, you get a floating point difference. And then you can do your matrix multiplication and all your vector stuff, and it's all very easy. That would probably be the easiest and fastest solution, and still have the some of the benefits, at least, of integers. But of course, it would suffer from some of the downsides of floating point. Of course. I feel like computers are fast, so why not go wide? Like, it'll be 4 times slower, but it's 4 times slower. Like, my goal with the physics is to make it like really exact so that I can do the minimum amount of work with no correction. So it like traces like sections of integers, and like it doesn't miss any. So there's no like gaps or double coverage while you're moving through the world, and it never calculates a collision twice. You intersect, and it calculates it once, and then you're inside, and it doesn't consider it ever again. Whereas with the Roblox physics, it's like it's constantly second guessing itself, and like sort of it doesn't do positional corrections, but it like goes, oh, did I forget to do that? No. Did I forget to do that? No. Did I forget to do that? No. Every game tick. And it catches a lot of problems and makes it very reliable, but it's not perfect. I've seen people like find very specific scenarios where they can jump through things. It was flying. I think they were flying through something. But yeah. Yeah, I'm gonna end it. I'm gonna clean my apartment so that when my parents get here, it's nice. Except for the floor, because the floor is never nice for whatever reason. The floor. Okay. Goodbye. What day is it today? Thursday. More tomorrow. Yeah, I'm really getting stuck. I didn't really have a big, like I thought the other things would take longer, so I don't have a big project to sink development time into while planning ahead. So this is sort of just raw planning and like flailing about trying different things, really. Hopefully it's still at least a little bit interesting. The ramblings of a madman. I did make a good algorithm implementation of Trey's push solve. Just the math needs this not floating point, the fixed point wideness